So in this unit, what we're looking at is we're looking at something called quadratic equations. In order to be a quadratic equation, we'll look here. In order to be a quadratic equation, yes, it has to be second degree. What it means is degree of 2. So you got to have an x squared in there. Not an x cubed, not a square root, nothing like that. It has to be an x squared. And the standard form of the equation has to equal 0. That's what makes it an equation, is the fact that it has an equal sign. So in this case, everything's going to equal to 0. So here's a nice little example where you're just going to have to figure out what does x equal to in order to make this entire equation 0. That's our primary focus for this entire unit. What values of x will make this 0? That's really, really important. So here's a little blast from a couple of podcasts ago. Something called a root and another one called a 0. Right? Now, roots of equations, these are the solutions to the equations. Now, doesn't necessarily mean that 2x squared plus 12x plus 16 has to equal to 0. That could actually equal to a number, and then we have to figure it out. Okay, but a 0 of the function is actually where the entire function does equal to 0. So you could have like an x squared plus 10x plus 5. That has to equal to 0. That's looking for the zeros. Now, zeros might be something you've heard of before in a previous podcast, because in fact, zeros are related to the x-intercepts of the graph. What do I mean by that? Do you remember this from a couple podcasts ago? We had some sort of parabola that went like this, and it said, what are the x-intercepts? And you went out and you found the x-intercepts to be this guy and this guy, and you went onto the calculator, you did second calc, and then you found out that there was a wonderful thing there called a 0. And that's what helped us find these two values. And why were they called zeros? If you remember correctly, because this is an x-intercept, that means y equals to 0. So they just kind of carried on that name of 0 because y equals to 0. So find where it is 0, find the zeros. Okay, so before we go on, let's go into something called solving the quadratics, talk a little bit about possible names that you may see. And it's actually, we're going to have all kinds of other additional names that we're going to put onto this a little later on in upcoming podcasts. But if you look at this, it says solving for quadratics. Yeah, you got to have an equal sign. Next thing is make the y equal to 0 or the f of x equals to 0. That's going to help things in solving. So here we go. When you're trying to find an x-intercept, yep, let the y equals to 0. Now, look over here. When you're trying to find the zeros, look at the difference between these. Really, there is no difference, just a little technicality. Zeros mean functions. X-intercept means y equals to 0. That's it. But they virtually mean the same thing. Look at this guy. When you're finding the roots. Roots, what you'll have to do is you'll end up having to factor the quadratic. And factoring goes all the way back to Math 10C, and we're going to look at some really cool factoring. So you factor it and then you solve for the zeros. Solutions means, well, some sort of function may actually equal to a number. So that might be a little bit different. That number could also be, guess what? Could also be 0. So solutions basically at this point in time has 4 names. You can call it a solution, you could call it an x-intercept, you can call it a root, you can call it a 0. They all pretty much mean exactly the same thing, which is kind of weird. But I guess the use the name just depends on the moment. Now, let's go on. How do we figure out the root? Now, I wrote it out here for you on this podcast, but I've also got the calculator running in the background, and I'm going to show you actually how to do this. So what are the roots of the following equation? Well, it's not an equation yet. It's not an equation until you make this equal to 0. Now it's an equation. That's a really, really, really important point. So the whole thing is you can see that x squared minus 10x plus 25 actually gives you an equation that we've listed here below. That's an actual picture of the calculator. And I'll prove it to you. X squared minus 10x plus 25. Let's put it in here. If you don't remember how to do that, that goes right into your calculator right here. So x squared minus 10x plus 25. Let's just confirm that and make sure it's the right one. Yeah, there it is right there. Now, boom, go back to your calculator. If you hit graph, boom, you're going to get a beautiful graph just like I printed out for you earlier. Now, the cool thing is you'll notice that we're now looking for this. Check it out. It says, what are the roots? Okay, roots is when the function equals to 0. All right, so that's where it meets up right there. So going to our calculator, and I know I've printed it off for you here, but I just want to go through the calculator and go through the entire procedure again, just to make sure you know how to do it. You hit second, you hit the trace button, which actually gets you to the calculate page. Go down to 0, hit enter. Now, you want to find this root right here. So first thing that you'll notice that it asks you for the left bound. So you want to be anywhere on the left-hand side of this thing, somewhere in that neighborhood there. Okay, so notice right now the calculator, and let me get rid of this part here. You'll notice that the calculator right now is at x equals to 0. And if you notice, this is where x equals to 0, and it's way the heck off the screen. So you won't even see the star at all. So start moving it this way. Start moving the star that way by pressing this button. Okay, and you'll see that it actually shows up right away. Look how that number is changing, 1.1, 1.6, and then suddenly it shows up. There it is. Now, what I always tell my students is get very, very close to this, or the root or whatever, but get close to that red dot as possible. Not extremely close, but kind of in the vicinity. That helps the calculator to say, oh, I'm zeroing in on that. Enter. Now, notice what it says now over here. It says find me, and I'll just erase this. It says find me the right bound. Okay, so now you want to be on the right side of this dot. So somewhere in this neck of the woods up here. Okay, so let's mouse over. Down, 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 down. And you'll notice that this calculator actually put a little bit of an anchor here with a dotted line. Some calculators will put this dotted line, some won't, and your ones will. So you mouse over to that side, hit enter again, and you'll notice that the other anchor is down. So it's basically showing you the root is between those two arrows, somewhere in there, right? And then it asks you to guess. Well, you're not going to guess. You're going to let the calculator do the guessing. Just hit enter. Okay? And look at that. It gives you a value. Now let me erase this and let me talk about this value a little bit. This gives you 4.99999 and goes on and on and on. One of the problems with this calculator is that it likes to round. Right? And because it rounds in its calculations, you may get some crazy decimals. And that's one of the crazy decimals we're talking about. So when it's actually that close to 4.999, just say it's 5. And then, of course, that's when your y equals to 0. So the coordinate is 5, 0. That, sports fans, is your root. Now, that's a point. What I drew here was a point. That's not officially a root. A root deals with just the x. Now, you're probably saying, well, why? Why is that? Well, look at the original equation. The original equation was x squared minus 10x plus 25, but because this has a y, it gives you the y value, which is 0. But what did you notice when you actually are solving this on the previous screen? That equaled to 0. That tells you there is no more y. The y is gone. The y is 0. So the only thing that this question wants, is it wants to know what is the x value. So the root is actually x equals to 5. You do not have to put the y down. Never, because the y is always 0. And because you made it 0, it no longer appears. That's really, really, really important. So only the x values from now on. Okay, so let's recap. Let's see what I did here. If you look at this, again, same thing. Here's the steps to find the root. Okay, first, plot the graph using the y equals 2 button. Put your equation in there. Okay, then visually identify the root. I visually identified it. There it is. The second thing you want to do, or the third thing you want to do, is second, right, and calc. And once you've done the second calc, keep on going. Menu appears, select the 0 every single time. And then left bound, right bound. Here we go. There, as long as this is on the left, that's all that matters. Okay, hit enter. Move over to the right side. As long as that's on the right, hit enter, and then it's going to say guess, and all you have to do is hit enter once, twice, and there is the 0. Okay, notice the y coordinate is 0, so all you need to put in is the x coordinate, which in this case is 5. Look how I did the exact same question. Remember what we got as an answer? 4.99999. Look what happened when I did this the first time. It gave me 5.000000. See how the calculator kind of messes up the calculations on that. So what we're going to do over the next couple of podcasts is I want to actually go in and do a whole bunch of examples that are going to be a lot faster than this. I'm sorry I'm taking so long on this one, but I think it's really imperative that we understand how to do this properly.